Let's continue with chapter 5. Previously, we have done chapter 5a, which is hardware interfacing. And let's continue with this next part, which is output components. And for this particular video lecture is about 7 segment. Output components, 7 segment display. 7 segment display is a display which being arranged to form a single digit, right, from 0 to F. It displays is still being used in the industry due its robustness in terms of temperature, visibility, and wide viewing angle. As compared to LCD, the 7 segments is actually way much more cheaper than LED. LED display or screen type of display. There are 2 types of 7 segments built up in the form of common cathode and also common anode. With the common cathode display, the pin must be connected to 0 volt or ground. And the LEDs are turned on with a logic 1. Meaning you give logic 1 equals to on, 0 equals to off. Right. For the common anode, the segments are turned on with logic 0, meaning 0 equals to on, 1 equals to off. Right. This is for common anode. Okay. This is for common cathode. All the timing signals for the display are produced by the program, meaning you have to write a program to turn on and off each of the LED in the 7 segment display. If you can see, this is actually one LED, this is one LED, there is another one, and so on. So you turn on each LED. So how do you turn on LED? Remember, from your microcontroller, it goes to a resistor and then your LED and then ground. So this is for common cathode, which means you turn on the LED by sending signals 1 and 0 to turn off. Common anode is the other way around. The display can be configured as an up counter, down counter, and can produce a number of messages using letters of the alphabet that can be readily displayed. So the letters is from A until F. Up to your creativity, that you could have something more than that. So it actually depends on, but the limit is just all the 7 LEDs, which is why we call it 7 segment. So the display can also be combined to display 2, 3, or more digits, meaning you have to have more blocks of 7 segment. Right, this is how we turn on the 7 segment display. If you look here, it is like an LED. Usually we have this represented. The first one, the topmost is LED is we label it as A, the top right B, followed by C, down right, and then the bottom is D, down left is E, top left it's F, and then the middle one is the G. And then there's another one which is a decimal point. When we do the programming, we recall it as H. Right. So if you remember from our previous part of this top chapter, that you need to have some minimum circuit configuration or hardware configuration, which involve crystal and capacitors, and then we have reset circuit, and then we have the rest is not really significant components circuits that is required, but you need to have VDD and ground, which means in this case it's 5 volts, and ground, which is 0 volt. So the way you wire the 7 segment will determine what kind of data that you need to send. right? For example, this is connected to port B from B0 until B7, and then this wires goes to each of the pin. Okay, so A is connected here, B, and so on until H. Of course, through the resistors. The resistors value is 330, standard for an LED connection. Right, so let's figure out how does this 7 segment is represented in hexa. Right, you can use during programming you can use numbers like decimal, binary, and hexa. But it's up to you. To use decimal is a bit difficult because you need to interpret from binary to another number, and especially in decimal. So if you know a number in decimal, you need to convert it accordingly. Right, but for this case, for 7 segment is slightly different. It's not a straightforward conversion. It's because that the way we wire the 7 segment. For example, if we look at the previous slides, here if we wire our B0 to pin A here, goes to the LSB, and then B7 goes to H, which is the MSB. Right, so in this case, here we have the B7 as the most significant bit, and B0 is the least significant bit. So this is how we wire them. So let's say you want to turn on number 0. Okay, if you look at this one here, this part here, number 0. How to turn on number 0? You have to have A, B, C, D, E, and F. So if you plot in the table here, A must be 1, B, C, D, E, and F. So G must be turned off, and H just turned off. It's just a decimal point. We don't really need it. So according to this, what is the number in hexa? Here we have 1 here is 3, and these are F. Right, how about number 1? Number 1 we have, so we have to turn on B, and then we have to turn on C. So that's our number 1. So B and C only. The rest are 0. So this number is represented by 0, 6. And number 2, let's look at number 2. You have to turn on A, B, this one is off, G, E, and D. So you can have that as number 2. So you have A is on, B is on, C is off, D is on, E is on, F is off, G is on, and then off. So what's the number we have here? 5, and 1010 is A, 11 is B. All right. And then number 3. All right, number 3. How do we present number 3? We have to have C turn on, A, B, C, D, and G. So A, B, C, D, E is 0, F is 0, G is 1. So what's this number? This is 4F. Okay, so you can continue until it's finished. So basically this is how you write a program in assembly, and this is the number that you have to send to the 7 segment, or if you in the previous case, the number that you have to send to port B. Right, so basically I've done this for you. Let me just delete the rest of it. Okay, so I just shown you how to get that done, how to get that number to represent the decimal in 7 segment. Next, If you were to write in C language, this is how to do it, but we are not going to do it in the C language this time. Okay, this is C language. You have to, as usual, you have to set port B as output, and then what this program is doing is send number 1, number 2, number 3, number 4, and so on. So meaning send number 1 and then delay, send number 2 and then delay, send number 3 and delay for 1 second here in this case. So what you will get is something like, let me see if I had that in my Proteus. Let me try to open up the Proteus program code. Right. Okay, so you can see this is a program that is displaying the number from 0 until 9 and then repeat it again. So how to do this program? You have to have a lookup table. Remember our lookup table in chapter 4 or chapter 3? Chapter 3 or chapter 4. You have to look back at the previous videos that I have prepared for you. So this is how we turn on the 7-segment LED by, let me, if I can zoom in, right? So you can see these are the status of the pin, right? So these are the pin, the status that we send to port B, and it will display accordingly. Remember, you have to create a delay program as well. So your delay program will determine how long it will take for the numbers to change. Right, let's go back to our slides. Okay, so so that is the slightly advanced program. Let us go through some simpler program that is given for you here. So let me go through one by one. Right, we start with as usual preprocessor directives. Okay, origin 00, go to main where is the starting of the program. You can use whatever the level you like, start, main, or begin, or whatever, as long as you understand it, what does that means. And then we have this declaration. Okay, variable declaration is just for the assembler. It's not for the machine or the PIC, because what assembler do is convert this R1 into this address basically. So whenever you see R1 here, it's actually it's being represented by the address 0 times 25 for R1, 0 times 27 for R2. Right, let's put that besides that. When we start the main program, as usual, number one, what we do is we set the IO. Okay, we do this all the time during our lab, during our programming session. We always do this. We have to set the input and output. So how to set the input and output? You have to use the bank select, go to the bank 1, right, to set the bank 0 or bank 1, I can't remember, but bank select is easier for you to program, because you don't need to memorize whether it is in bank 0 or bank 1. So if you need to use trace B, you just bank cell trace B. That's easier that way. Okay, so in this case, we set port B as an output, right? 0 times 0, 0. So if in case you need port A, as you can see in my Proteus program just now, the simulation that you can see, it has port A as an input. There's one switch connected to the input. Let me see if I can show you this. Yeah, here. Okay, port A as an input. So if you need that input, so you can have this turn on. So you have to just add move LW 0 times 0 1, move WF, trace A, just like that. Okay, so that's just an example if you need to use it. And then bank cell port B, move LW00, move LW port B. So we already set port B as an output. Here we just need to send 00 so that whatever that is being turned on previously is turned off. So the whole LED is turned off. And then you can send the output data that you want. What is 06? 06 is number 1. Here in this case, it means you send number 1 to port B. Oh, I cannot delete this. Number 1 to port B. What does that mean? Sorry, not number 1. 06 to port B, but here actually you send number 1 to 7 segment. Okay, meaning on the 7 segment you want to display number 1, and here 5B means you want to display number 2. Remember in this part we have a call delay. So call delay is so that LED needs time to light up. Okay, if you're doing it too fast in milliseconds or microseconds, your eyes will not be able to see that the LED is already on, because it's very fast on and then off, or maybe change. So the way to do it is to call delay at least once, at least half a second, or usually we just use 1 second. So the delay program code, you have to write it, you have to calculate it, how to have an actual 1 second delay by calling the subroutine, going through the loops again and again, and return from subroutine. So you need a total of 1 second. Right, so from now I will be giving you a task for you to write a 1 second delay program code. You will be doing this over and over again, because you will need this like many times. So make sure you do this program code, so that anytime you need it, you can just write it on top of your head. Okay, make sure you do it up to the point that you remember the number that is required. If not, every time you do, you have to calculate each of the instruction cycle and the timing that is required for the whole delay program. Alright, next. This is another way of to write 7 segment display counter. As you can see previously in the simulation is actually a counter. So how to do it? You need to use lookup table, as I mentioned. Okay, lookup table, you have to refer to previous video or notes in the chapter 3 or chapter 4. So how to use the lookup table? You just call this subroutine. Right? So it will take the number that you need and then display it. Okay, let's analyze this program code one by one. As usual, at the start of the program, you have a bank select, and then IO declaration, right? Trace A, trace B. So in this case, port B as an output, port A 0 as an input. And then bank select port B, you initialize it, meaning you turn off all LEDs. Okay, 00 send to port B, and then move 0, move to count. We have to check what it's needed, what is this being used for in this program code. And then once you have done that, there's a loop here. So in this case, call counter, call display number, go to loop. So this program will revolve around this part. Okay, so this is an example of using subroutine, the easiest way to do it, right? So when you run the program code, okay, when the program runs, it will run one by one. Up to this point, you just call counter, meaning you get somebody else to do it for you, which is the subroutine. Once you're done, the subroutine will return to the main program. So this basically is the main program, your main program. And then you have the subroutine. Okay, in this case, the counter subroutine. So what does it do? In the counter subroutine, also we have call another subroutine. Okay, here call check max, which means maximum number. Call check min, which is the minimum number. So what does it do? You have to check what does the subroutine do. Okay, move LW 0. Okay, let's look at the subroutine check max. Move LW 0 times 0A XOR WF count. So what does it mean? A is count is 0 0. Right? What is A? A is number 10. When we XOR here, what does it do? We compare to, okay, and then bit test F skip if set, meaning if Z equals to 1, meaning if the result is equals to 0, then skip. If the result is not 0, then return. Okay. And then if the result is 0, move LW 0 0, move WF count, and then return. So what does that mean? Meaning if check max mean if the number has come to a final number, which is 0 in this case, and then if it's 0, then return. Okay, if it's if it's 0, reset to count to 0. If it's not 0, then come back to the counter subroutine. And then call check min. So it will do almost the same thing as the check max, but except for the number that you're gonna do. Okay, 0 times FF XOR WF count 0. 0 means you save it on the working register. And then tef if set, if it's the same, then return. If it's not the same, if it's not the same, then return. Meaning check max and check min, it checks whether the current number is it exceeding the maximum number, or is it exceeding the minimum number. Why do we use FF? Meaning if it's a 0, then we'll have to restart again, right? Where we move LW 0 times 0 9, move WF count. Meaning if the current number is up to the 0, then you start with 9 again. So what do we do next? Move F count 0, meaning you take number that is shown in the count register and then put it in the working register. 0 refers to W, yeah, working register. And then call 7 segment. So when you call 7 segment, it will display the number, the current number that is required. Bit test F skip if set, port A 0, meaning you check port A whether or not port A is port A in this case is usually a switch, right? So whether or not our switch is on or off. So, or maybe the switch is used to do the counting, right? And then increment count. So can you guess what does this program do? Right. So that's the counter, meaning the program do the counting, how many times the port A is turned on and off, and then whether or not the number is reaching the 0 or reaching the maximum number. All right, and then call display number. Okay, just now when you call 7 segment here, in this case, when you call 7 segment, it will return the current number. Let's say the count is 2, so you have to send 0 times 5B to port B. So it's just to find the correct number to display on the 7 segment. So when the count is 2, then you will display number 2 on the 7 segment. So to display number 2, you have to use this 0 times 5B, send it to port B. Okay, so that's the function of 7 segment. So when it's returned, working register contains this value, which is the number to be sent to port B. So the next task is call display number. So remember, the working register is having this number 0 times 5B. Move WF port B, call delay. So 5B goes to port B and then call delay. And then return and then go back. Okay, doing the thing again and again, doing the counter. So as you can see, there is a delay subroutine here. Okay. So my expectation for the students is to be able to write a delay program code and then be able to count how much is the delay, depends on the crystal frequency. Thank you for watching. Don't forget to hit like and subscribe and leave a comment in the section below.